Subscribe to our channel by clicking the subscribe button. Click the bell button and enjoy the latest uploads from our channel.
Modern traffic routes require a variety of bridge construction for road, rail and water. They have always been a special challenge for planners, engineers and contractors. For decades, Perry has helped with innovative formwork techniques and comprehensive expertise in successfully completing bridge projects. The experience gained from a multitude of completed bridge projects flows into every new Perry solution. Development, construction and manufacture come from one source with Perry. Perry material is available worldwide. Perry formwork specialists provide advice and service on site. Satisfied customers all over the world are the basis for the Perry success. Modern bridges consist principally of the following components: abutments, superstructure, and the parapets. Long bridges are supported by piers. The structural shape of a bridge is mainly determined from an aesthetic point of view, subsoil conditions, and the shape of the existing ground. Cable-stayed or suspension bridges are constructed to deal with large spans such as deep valleys, wide rivers, or shipping routes, for example. The extreme loads in these structures are carried by pylons. The largest free spans can be bridged over with suspension bridges. Perry provides the right formwork and scaffolding solution for all components of a bridge. For foundations, abutments or piers. Trio, the universal framed panel formwork. Trio structure for special concrete surface finishes. Safety is maintained at all levels. Trio with built-in platforms and ladder access. Vario, the girder formwork with a versatile lattice girder GT24. The fair-face coupling guarantees excellent concrete surfaces free of lipping. The folding platform FB180 or the Perry climbing scaffold CB, KG and SKS for constructing piers. Perry supporting scaffolds for constructing the main body of the bridge, for example with the lightweight aluminium multi-prop prop system. The HD200 heavy-duty props for taking high loads, in aluminium or steel. Stacking tower ST100, the man-handled frames for all heights. Fast and safe working on the edge of bridges. Perry cantilevered parapet carriage and cantilevered parapet platform. ACS, the self-climbing formwork. With over 30 years of experience in climbing technology, Perry also provides the right framework for the construction of pylons and high piers. Safely climb with Perry ACS. For any shape, in any weather, up to any height. When using a falsework construction method, the formwork for the superstructure is supported by scaffolding that in turn determines the required shape. This method is used when the height of the bridge and the existing ground allow for an economical construction. 3 similar bridges were constructed for the southern approaches to the Westerschelde tunnels in the Netherlands with one falsework system. The same set of Perry formwork was used for all 3 bridges. It consisted of the heavy-duty prop system HT200, stacking towers ST100 and multiflex slab formwork. Rows of primary beams using the HT200 system were erected in the area of the site roadway passages and the embankments. The lightweight construction of the stacking tower ST100 components allowed erection to be made by hand. Everything is simply pieced together. The stacking towers grow in increments of 500 mm for each layer. GT24 lattice girders were placed on the head spindles to take the superstructure formwork. With the steel combination method of construction, the slab is constructed on a supporting steel framework. For longer bridges, a travelling formwork is often the best economical solution. Not far from Zurich main railway station, an existing railway bridge was modernised. A formwork carriage with Perry was used for constructing the new superstructure by the steel combination method. Erection and striking was made with the integrated hydraulic system. Moving with 120 tons construction was achieved with 4 electric motors. The formwork carriage had to be articulated because of the changing small bridge radii. Work could proceed comfortably below the bridge from the travelling working platforms. The fresh concrete loads were transferred into the steel beams of the bridge through movable bearing tables. The Perry formwork carriage was ready to be used for the new cycle in the shortest possible time. The prominent pylon of this bridge in Warsaw was constructed with Perry self-climbing formwork ACS. The Perry up rosette scaffold was used for installing the cables. Perry up proved to be just as good as a supporting scaffold for constructing the slab at the pylon and the abutments. The 490 metre long and 31 metre wide bridge in steel combination method was constructed with 2 Perry formwork carriages. This type of construction was very cost-effective because it consisted mainly of standard components from the HD200 system. The complete carriage was moved hydraulically. Formwork between the steel beams had to be erected by hand. For this reason, the lightweight Perry Skydeck slab formwork was used. In the incremental launching system, the bridge superstructure is constructed in a static formwork bay and launched in one piece. A so-called launching nose bridges over the next span. One condition for this construction method is a constant bridge radius. Typical cross-sections are hollow box sections, or beam and slab. Perry formwork was used for both the piers as well as the superstructure for the Foreland Bridge to the new Rhine Bridge south of Strasbourg. This bridge was constructed with the incremental launching system. The external formwork consisted of vario steel wailings, GT24 girders, heavy-duty spindles, and the whaler hinge designed especially for bridge construction. Launching the cycle begins with hydraulically lowering the external formwork. Every bearing point was controlled from the working platforms on the piers during the incremental launching. The launching is controlled from the work control chamber. The hydraulic jacks were supported on the abutments. Slip pads of Teflon were placed between the body of the bridge and the bearing points to reduce the friction. The reinforcement for the next increment was prepared ahead during the launching process. External pre-stressing units resulted in complicated geometry within the body of the bridge. A light and flexible formwork system was required for economical working. That is why Skydeck aluminium slab formwork with multi-prop props was used here. A 4-lane bridge was constructed for extending the Federal Roadway 227 near Essen. Two 330-metre-long carriageways were constructed using the incremental launching system with one set of formwork. Perry systems were used for all bridge components, Trio for the foundations and abutments, Vario wall formwork on KG platforms for the piers, Vario steel wailings and GT24 girders for the superstructure, and Skydeck for the slab in the hollow box. Access to the platforms was gained by Perry up stair towers. Because of the unusual gradient of 1 in 17, the incremental segments were not pushed out but pulled out hydraulically by steel cables. To be correct, we should therefore speak of incremental pulling. During the final launch, of 15 in total, a concrete section weighing more than 10,000 tons had to be pulled into place. This bridge was constructed over the Judental in Thüringen within the framework of the A71 Autobahn traffic project. The formwork for the incremental launching plant consisted of standard Perry components. With its continuous row of holes, the universal steel wailing provided a number of fixing points for push-pull props, or the external handrail holder, for example. The universal coupling connects the steel wailings. It also provides many fixing points. Because of the quick-setting concrete, the inner formwork could be struck after only 4 hours. Special brackets enabled the fast movement of the 27-metre-long slab formwork carriage. 190 square metres of slab formwork were moved to the next cycle within a few minutes. The formwork was erected for the next cycle in a very short time, using the multi-prop props. The Großheim Valley Bridge near Pirmasens. Apart from the Perry formwork for the incremental launching system, the piers and the abutments, Perry scaffolding was also used for servicing the slip bearings on the piers. The solution, using standard Perry up components, enabled safe working. Striking the scaffold after completion of the bridge was able to be made by hand. In order to avoid the need for individual stair towers to the 55-metre high piers, a travelling access system comprising of standard peri-up system components was used to gain access to the working platforms. This created a reduction in time spent accessing the working platforms, resulting in a considerable increase in cost savings. With the launching beams construction method, the bridge superstructure is constructed in cycles. The formwork is assembled on a supporting scaffold that is pushed over temporary piers or brackets. This construction method enables bridges with varying radii to be constructed. The 650-metre long Haseltile bridge was constructed in Thüringen for the new A71 Autobahn. A launching scaffold with added supports was used for constructing the bridge. Apart from supplying the formwork for the bridge superstructure, Perry also delivered the formwork for the piers and abutments. Launching was made with the help of hydraulically powered cable winches. The formwork was divided before each movement cycle and pushed transversely. It was thus able to travel past the piers on the outside without hindrance and without the need to be taken apart. In Portugal, in the valley of the river Filho, a bridge was constructed for the A15 motorway with a complete Perry solution. The Perry launching beam was especially economical, because the loads here were transferred directly into the piers. The otherwise necessary temporary supports are omitted in this type of construction. The complete formwork for webs and roadway slab was suspended at the top on the lattice girders by tension rods. A load of up to 1,200 tons was taken by the launching beam from a span width of 40 metres and transferred into the piers. Erection and striking was made with the help of electric cable winches. The formwork folds away underneath so that it can be easily moved past the piers later on. The beam, the prefabricated reinforcement and the formwork were moved as one unit. 1,000 square metres of formwork were thus moved in the shortest possible time. Hydraulic cylinders pushed the whole construction in 1.4 metre stages to the new position. After a few metres, the launching nose reached the next pier. The launching beam was guided onto the middle bearing point and the loads introduced into the bridge piers. The bridge itself was therefore only minimally loaded when moving the 400-ton formwork construction. As soon as the final position was reached, the formwork was able to be re-erected. The formwork units were lifted with the cable winches and fixed to the beams with tension rods. One complete cycle was constructed each week in this way. An hydraulically driven launching beam was used for this bridge in Katowice. The special demands on the Perry engineers were completely different piers, the continually flowing traffic on a main road below, as well as the very narrow and countering bridge radii. The false work for the starting cycle was of multi-prop towers. The Perry cantilevered parapet carriage was used at the edges of the bridge. The construction of the launching beam enabled fast-moving and safe working. The formwork was removed when the carriage beam was lowered. After removing the ties, striking was carried out hydraulically. The folded formwork was moved outwards with chain winches to be able to move past the bridge piers. When the front bearing was completed, the movement of the launching beam began. The 88-metre-long beam construction could also then overcome the tightest bridge radius of 350 metres. In addition, the travelling and transverse movements were made alternately according to a sequence plan within precisely determined working stages. After completion of the first carriageway, the launching beam was able to independently travel back. Moving the second half of the bridge was made by transverse movement of the hydraulic system. Erecting the formwork for the 44-metre-long bridge spans was also quickly carried out. A concreting cycle of 11 days was achieved by the site with this Perry solution. In the balanced cantilever method, the bridge is constructed equally in both directions, starting from a massive pier. The cantilevered sections hold each other in balance. Span widths of over 300 metres have been achieved by the balanced cantilever method. A 465-metre-long bridge over the River Rhine was constructed in this German-French joint project. It relieves the old Europa Bridge between Strasbourg and Kehl. A width of 205 metres had to be spanned to allow for shipping. The movement of craft could not be effected, even during the construction period. That is why the balanced cantilever method was used. First of all, the pier tables were constructed. Their complicated geometry was easily formed using standard components from the flexible Vario program. The bridge itself was constructed symmetrically about the central pier tables. Hollow box and carriageway slab were concreted in one pour, monolithically. Pre-tensioning was started 2 days after concreting. The launching carriage with the external formwork was moved hydraulically to the next cycle position. In the final position, the formwork was adjusted to the new cross-section and then the hollow box reinforcement fixed. The internal formwork was moved on rails. With the prefabricated concrete construction method, prefabricated units are placed on supporting rows of primary beams. The carriageway and the bearing areas are usually constructed with in-situ concrete. Perry provide various systems for supporting the prefabricated concrete units. An 8-kilometer-long bridge forms part of the Öresund connection. Prefabricated units 140 meters long, 25 meters wide and 7,000 tons in weight were used here. The two-story carriageway was assembled with the help of the world's largest floating crane. The prefabricated units for the 1,100-meter-long viaduct were constructed in the harbour of Malmö. The supporting steel constructions, with the connections for the sloping cables, were scaffolded with Perry multiprop tables. Over 11,000 multiprop props, 18,000 multiprop frames and 48 kilometers of GT24 lattice girders were used. The handling advantages of the Perry products proved especially productive here. The prefabricated units for the connecting bridges were constructed in the Spanish harbour town of Cadiz. A Perry solution was also used here. A 140-metre-long formwork carriage was used for this. 48 bridge components were constructed and then transported to Sweden. Perry added to the success of this centennial structure with their experience and expertise. A superlative 2,460-metre-long cable-stayed bridge is being constructed in the valley of the Tarn near Millau. The pylons of up to 342 metres in height will be constructed with Perry ACS self-climbing formwork. Almost 700 tons of formwork equipment from Perry Weissenhorn was transported to the south of France. Over 6,500 square metres of formwork, almost 200 ACS self-climbing units for the outer formwork, and 100 SKS climbing units for the inner formwork. Perry formwork specialists provide advice on site both for the assembly as well as for the use of the formwork. The pylons are growing as planned in concreting cycles of 4 meters. Decades of experience, innovative formwork and scaffolding techniques, trend-setting engineering work, and through all this, economical solutions. Perry, the partner for bridge building.
Subscribe to our channel by clicking the subscribe button. Click the bell button and enjoy the latest uploads from our channel.